amazing people, students, and all the lovers of chemistry out there. I'm super excited to be here with you on this all new series that we're starting off with today's episode. And in this episode, we're going to be looking at the concept of how to name organic compounds. So I'd like you to do me a favor by relaxing, sitting back, and enjoying every bit of today's video, because this has been broken down into a series with a number of videos that will be dealing with each concept step by step. All right, so let's get into what we have for today's video. Now, we're going to be learning how to name organic compounds, but before we do that, it is very important for us to know what exactly an organic compound is. So what exactly is an organic compound? An organic compound is simply a substance that is built mostly of carbon and hydrogen. So whenever you have the combination of carbon and hydrogen, what it usually produces is what we know as organic compounds. Now, permit me to say at this point that if an organic compound were to be a human being, then its spinal cord or its backbone would be carbon, because carbon, you see, serves as the framework and the foundation upon which all organic compounds are built. In fact, one of the major characteristics of organic compounds is that they all contain carbon, and in most cases they contain hydrogen as well, and these compounds form the basis of all life on the planet Earth. They also contain oxygen in examples like alcohols. Okay, so alcohols are also organic compounds. They also contain oxygen, and they can also contain nitrogen, sulfur, and halogens as well. In as much as they can contain all of these elements, it is important to also know that the basic definition of an organic compound is that it is a compound that is made mostly of carbon and of hydrogen. Now that we have put that in place, let's see some examples of organic compounds that we have in our everyday life. Now, if you use your cooking gas for maybe you have a gas cylinder in your kitchen that you use for cooking, that contains a gas that we know as methane. Now, methane has the molecular formula of CH4. In other words, it has one carbon atom and 4 hydrogen atoms. Now, that is an organic compound, and it is also called a hydrocarbon. Another example of an organic compound that we have is the ethanol, the example called ethanol. This is found in alcoholic drinks and in hand sanitizers. And the third example that we have that is found in your body is glucose. This is the sugar your body uses for the storage and deployment of energy. So you can see organic compounds are not just limited to chemistry in the laboratory. They also take place as far as the science of your human body is concerned. Now, if you have been noticing from the moment we started this video up until now, you'd notice that every organic compound we have been mentioning contains carbon. So a question to ask at this point will be, why all the emphasis on carbon? And I'll answer that question. You see, carbon is like a Lego block. Now, this is a picture of a Lego block that I have over here. Now, why did we say carbon is like a Lego block? One of the characteristics of Lego blocks is that they can be used to construct a number or a variety of things. You can use a Lego block to construct a car. You can use it to construct a house. You can use it to construct even a brick wall. Just one object being used to construct a number of things. Now, applying that to carbon is that carbon can also be used to connect in many different ways to form different compounds. Compounds that have long chains, compounds that have ring structures, compounds that have branches. And that is one major reason why we have millions of organic compounds scattered all across the world. In every strata and every aspect of life that you find organic compounds, you discover that organic compounds are so many you can hardly get to the end of the list. And that's because carbon can be used to connect in diverse ways. Now, this is one reason why naming organic compound matters in chemistry. Imagine with me, you walk into a a pharmacy or a chemist and you say, please give me that white powder that treats pain, it's not going to be helpful, right? Because there are different white powders for different purposes. Rat poisons in many cases can also be a white powder, and it doesn't treat pain, it gives pain. So if you get into a chemist and you say, give me that white powder that treats pain, that's not going to be a helpful way for identifying a drug. So in chemistry, it functions the same way because we need names that tell us exactly what the structure is. We need names that allow scientists all over the world to understand the same thing. So for instance, now let's say you walk into a chemist and you say, give me aspirin. Now, aspirin in Nigeria is the same thing as aspirin in the US. It's the same thing as aspirin in the UK. Why? Because the name has been identified globally. Now, it works the same way in organic chemistry and in other facets of life. Having names helps us to avoid confusion because many compounds can look similar. Now, speaking of similarity, here is one example. Butane and isobutane, I have their structures both listed out here on the screen. This is the structure of butane. You can see it over here. And here is the structure of isobutane. Now, both of them have 4 carbon atoms. If you count with me, you can see carbon atom number 1, carbon atom number 2, carbon atom number 3, and carbon atom number 4. Same thing goes for here. We have 1 carbon atom, 2 carbon atoms, 3 carbon atoms, and 4 carbon atoms. Both of them have 4 carbon atoms, but their structure and their uses are different. So we need clear names to know the difference. It's just like having a set of twins. The two of them might look, alike, but then their names are what helps us to tell them apart. So naming in organic chemistry is very useful because it helps us to tell different compounds apart. So now that we have talked about that, that brings us to the concept of the overview of the IUPAC naming rules or system. Now, there is a system that has been put in place for the efficient assigning of names to different organic compounds, and that system is called the IUPAC naming system. IUPAC, by the way, stands for International Union of Pure and Applied Chemistry, and they created a system of rules that helps us to name compounds logically and consistently. Think of it as a naming formula. Once you learn the steps, you can name any compound anywhere in the world. So once the steps have been put in place, of which I'm going to be showing you in this video and in subsequent videos to come, you can name any organic compound that you want to. So what's the IUPAC naming method focused on? There are a number of things that the IUPAC naming method focused on. Let's check them out. The IUPAC naming method focuses on a number of things. First of all, they focus on how many carbon atoms are in the longest chain. Now, I'm going to be talking about the concept of what a chain means, okay? So, but for example, now, let's say you have 1, 2, 3, 4 carbon atoms in a parent chain. And carbon has a valency of 4. In other words, it can bond to 4 different other atoms. So now that we have 4 atoms in the parent chain, the IUPAC naming system focuses first on this. And because we have 4 carbon atoms in the parent chain, we have a name called BUT. It is a name that is used to identify and show that we have 4 carbon atoms. We're going to get into more details, okay? I just use this as an introductory concept. The next thing that the IUPAC naming method focuses on is on the types of bonds that exist. It is possible for carbon to have a single bond. It is possible for carbon to have a double bond. It is possible for carbon to even have a triple bond. And in all the cases, whether a single, a double, or a triple bond, there are names that are assigned to them. For example, when carbon has a single bond to another carbon, we use the name ANE, ANE. When it has a double bond, we use the name ENE, IN. And when it has a triple bond, we use the name YNE, IN. We're going to get into more details, okay? Now, the next thing that the IUPAC naming method focuses on is what else is attached. And when we talk about attachment, When we talk about attachments, we are simply referring to the substituent. We're referring to the substituent or the side group. Okay, and we're going to get into more details. For example, you can have branches, you can have halogens, you can even have alcohol groups as attachments and as substituents. And then the next thing that the IUPAC naming method focuses on is where everything else is located on the chain, and we're going to be dealing with all of this step by step. So now that brings us to the three-part structure of the name of an organic compound. Now, in order to make things simple, you can break most organic compound names into three parts. What are those three parts? You have the prefix, the name that comes first. You have the parent name, the major one, and then you have the suffix, the name, the part of the name that comes last. So this prefix here talks about the part of the name that comes first. This is the parent name, and this is the major part of the name that tells us most details about what the compound is. And then this is the suffix. This one comes last. Now let's see more details about these three part structure of naming organic compounds. So let's talk about the prefix first of all. So the prefix simply means the side groups or special atoms that are attached. For example, if I have a compound that has 4 carbon atoms, 1, 2, 3, and 4, and then on one of the carbons I have an attachment, let's say a methyl substituent. Now methyl is denoted as CH3. CH3 is called methyl. Just decided to bring that up. Now you can see at this point there is a substituent over here, and it is on this carbon over here. Now when we want to name this compound, the first thing that we will do is to identify the longest chain. Now how do we identify the longest chain? We can start counting from here: 1, 2, 3, and 4. So that tells us that this substituent over here is on carbon number 2, which is why the name here is identified as 2-methyl. So when we want to start naming an organic compound, we start with the prefix, and the prefix is identified by all the branches that are not in the parent chain. This is the parent chain over here. We started counting from here all the way to this point. And you will notice that when we were counting, we did not count this guy over here to be part of the parent chain. So that means anything that is not part of the parent chain becomes a side group or a substituent. Now since this CH3 is a side group or a substituent, it means that it becomes a prefix. Now how did we identify that prefix? We did that by identifying its number. It was on carbon number 2, and then we called its name 2-methyl. Now the next thing is the parent name. The parent name simply refers to the number of carbon atoms that are present in the longest chain. Now when we were counting the number of atoms present in this chain, we counted 4 carbon atoms. Now in naming organic compounds, when you have just 1 carbon atom, you use the parent name called METH, meth. That is why methane has the formula CH4, because it is just 1 carbon atom. When you have 2 carbon atoms, you use the parent name ETH. 3 carbon atoms, PRO. When you have 4 carbon atoms, you use the name BUT. So that's this example over here. So when you see the parent name BUT, it tells you that there are 1, 2, 3, 4 carbon atoms present in that organic compound. That is why you have the meaning to be number of carbon atoms in the longest chain. That brings us to the next one, which is the suffix. The suffix simply talks about the type of bonds or functional group that are present, whether it is an alkane, which is identified by an ANE name, whether it is an alkene, whether it is an alcohol, and so forth and so on. We're going to be talking about that in detail, step by step. That brings us to this example. We have this example that says 2-methyl-butane. How did we come up with this name? Let me draw the structure first of all. 2-methyl-butane has this structure CH3, CH, CH, and then CH3. 4 carbon atoms. Okay? And then this is the substituent CH3. Now, how did we come up with this name? This is the structure of 2-methyl-butane. The first thing that they identified is the number of carbon atoms in the parent chain, or the longest continuous parent chain. Now, how did we identify it? We can start counting from the left side, which is here, or from the right side, which is here. Now, counting from the left side, we have 1 carbon atom, 2 carbon atoms, 3 carbon atoms, and 4 carbon atoms. 4 carbon atoms tells us that the parent name will now be BUT, which is but. Now, the next thing to identify is the suffix. Does it contain single bonds, or does it contain double bonds, or does it contain triple bonds? You can see all throughout the structure what we have are single bonds from A to Z. And when you have single bonds, it tells you that it is an alkane. And when it is an alkane, you use the suffix ANE. So you can see when we combine the parent name with the suffix ANE, that gives us butane. But now we're not done. Let's deal with the prefix. The prefix identifies any side group or substituent that is not in the parent chain. Now we've counted our parent chain from this direction to this direction. Is there any carbon atom that we did not count to be part of the parent chain? Yes, this one over here. And this over here is CH3, which has the name methyl. Now that we have its name methyl, let's identify the carbon atom that it is on. It is on carbon atom number 2. So to completely identify the prefix, we name it 2-methyl. That tells us that the methyl substituent is on carbon number 2. Then we can add the parent name and the suffix, which is butane. So that's how we came up with the name 2-methyl-butane. So now that we've talked about the prefix, the parent name, and the suffix, here is a class activity I'd like you to try out yourself. I want you to break this name down, 3-ethylpentane, into the prefix, the parent name, and the suffix. Alright, so you identify which part is the prefix, you identify which part is the parent name, and then you identify which part is the suffix. So now that has been said, it's time to call or draw the curtains on this video. Okay, like I said, I don't want this video to be extremely long. I want it to be short and placed in assimilable bits that you can watch step by step. So next up, we're going to be looking at the concept of understanding the carbon chain. How did we come up with those names, methane, ethane, butane, and all the anes and everything? We're going to be talking about that in the next episode. So if you have not subscribed yet, I'd like you to do me a favor by hitting the subscription button, liking this video, and turning on the notification bell icon. So when more videos like this come out, you'd be the first to be notified. Up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I'll see you in the next video.